Okay, I'm back with the second page here, and I'm going to run through these examples with you. This first example says find the derivative of 3x squared plus y cubed equals 5. Okay, well again, I could rewrite this as 3x squared plus f of x cubed equals 5. Or I could take it right with the y. And I guess I'm going to talk through both ways just so you can see that they're actually asking the same thing, okay? And either one, I'm going to start with this first one here. I'm going to write it again. I got 3x squared plus f of x cubed equals 5. And again, it asked me to take the derivative, and when it asked me to find the derivative, it's understood that I'm finding the derivative with respect to x. X is the independent variable, and I'm going to take the derivative of each individual part. And now, again, I'm taking the derivative with respect to x, so the derivative of 3x squared is going to give me 6x to the first. All right, this next term here, I've got the derivative of f of x cubed. I do have an inside function, right? I have this f of x inside of x cubed. And so the derivative of x cubed is 3x squared. Whatever was inside stays inside. Chain rule says I also multiply by the derivative of the inside function. Derivative of f would be written as f prime. Equals, okay, well the derivative of 5, that's a constant, is 0. Okay, now again, I could have just written this as 6x plus 3y squared times y prime equals 0. And I feel like writing it with the y's is just a little less messier. But the reason why I put it in terms of that f of x for you is because we are asked to find the derivative with respect to, it's hard to see, with respect to x. And so I was just putting things in terms of x for you. I'm going to stop doing that here when I go through this next example. My next job then is to isolate that y prime. So if I subtract 6x, and then I'm going to divide both sides by 3y squared. And if I simplify that, I get a negative 2x divided by y squared. And that is equal to y prime. Hey, by the way, that's the same as saying dy dx, okay? Now, I could, I'm just going to do a little line here. Let's see. I could have just taken it straight from here, okay? I could have written that I'm going to take the derivative with respect to x for each of these terms, right? Again, the derivative of 3x squared with respect to x is 6x to the first. And again, the derivative of this constant of 5, there is no x there, the derivative of a constant is 0. But see, I run into this issue here because I don't have an x, I have a y. It's the derivative with respect to x, but unfortunately I don't have an x, okay? And so again, here's what this means, this implicit differentiation. It means I'm going to take the derivative of the variable I see a y, I'm going to take the derivative of that y cubed. Derivative of y cubed is 3y squared, okay? But because this y is not an independent variable, I'm being asked to find the derivative of the independent variable, but y is not the independent variable. I need to multiply by the derivative of that function because the function y would be in terms of x. So again, if my independent variable x does not match the variable I am taking the derivative of, I still take the derivative of given variable and I multiply by the derivative of that function. Okay, another way to write this, one more way to write things, right, is that I'm writing plus 3y squared, and another way to write y prime is times dy dx, times the derivative of the function with respect to x. That's the same as writing y prime. And all of that goes back to this idea over here, where y is the same as f of x. I'm taking the derivative with respect to x. That gives me another y prime in there. Y prime is the same as dy dx. So many ways to write this. I personally think that the simplest way to deal with this is this way right here. Okay, keeping everything in terms of y's. And so that's what I'm going to do from this point out. D says that I need to find the derivative of this function. And again, I'm going to take the derivative with respect to x of each individual term. Okay, and so right off the bat, I have take the derivative with respect to x, but the function is 2y. That's okay. I'm going to take the derivative of 2y, that gives me 2, and I'm going to multiply by the derivative of that function. The derivative of y is y prime, or dy dx. Take the derivative of the function with respect to x, okay? Equals, all right, I have the derivative of x squared, that's 2x. And then I have the derivative of sine of y. Again, the derivative with respect to x where the variable does not match x. That's okay. That means I'm just going to take the derivative of sine. The derivative of sine is cosine of y. And I'm going to multiply by the derivative of y with respect to x. I need to get my function written as a derivative in terms of the independent variable. By the way, writing dy dx is the same as saying y prime. I do not prefer one over the other, so you pick a preference and stick with it, okay? But again, the whole idea is when you're taking a derivative and the variable does not match the independent variable, I am multiplying by the derivative of that function. My job now is to get the y primes on the same side. And my trick for doing this is saying, hey, this term has a y prime and this term has a y prime. So what I need to do is I need to rewrite by subtracting cosine of y times y prime, so that the y prime terms are on the same side. See, look, y prime and y prime, those two terms are on the same side. And I do this on purpose because now I can factor the y prime out of each term, right? If those are the only terms on the left side with a y prime in them, I can factor that y prime out, and that allows me to then divide both sides by that common factor. Divide both sides by the remaining factor. So y prime, or another way to put that is dy dx, doesn't matter, y prime and dy dx are the same, is equal to 2x divided by 2 minus cosine of y. Okay, hope you're still with me. Here we go. We're going to do another example. This is find the derivative of 2x cubed plus xy equals 9. Okay, and my first step here is I'm going to say I'm going to take the derivative with respect to x of each individual term. Okay, and so the derivative of 2x cubed, well, x is the independent variable, derivative of 2x cubed is 6x squared. Plus, all right, I'm asking you to take the derivative with respect to x. X is the independent variable of xy. First of all, this has a variable that is not x, so that poses an issue. And second of all, this is x times y. This is a product. I must use a product rule when taking the derivative of x times y, okay? So stick with me here, okay? I take the derivative of so I'm just going to put this in parentheses, indicating that this is the product rule together. Derivative of x is 1 times the second function plus, I take the derivative of y. I have to take the derivative with respect to x of y. Well, the derivative of y is 1, But because y is not the independent variable, I multiply 1 by, oh look, dy dx, okay? Let me run through this again. I have to take the derivative of y. The derivative of y is 1 times, well, I have to then write y prime. I am rewriting this so that I'm taking the derivative with respect to x. Writing y prime is the same as writing dy dx, and then I have to multiply by the first function. The derivative of 9 is 0, okay? So when I run through this product rule, again, product rule, derivative with respect to x of xy. I'm taking the derivative of x, that's 1 times the second function, plus the derivative of y is 1 times y prime. That's nothing new. The derivative of y is y prime. We've known that, okay? Times the original function. So that should feel familiar. That right there should feel familiar. The derivative of y is y prime, okay, times x. Now my job is to get this y prime by itself. So the first thing that I'm going to do is I'm going to subtract the 6x squared. And then I'm going to subtract the y. And then I'm going to divide both sides by x. And I get y prime, or that's the same as saying dy dx, is equal to negative 6x squared minus y all divided by x. Okay. F says find the equation of the tangent line. I can do that. Find the equation of the tangent line at the point 1, 1. Notice because I'm going to be given an implicit function that they give me the entire point. So I give you the directions. The first thing that we need to do is we need to find the derivative. So I need to find the derivative, oh boy, excuse me, with respect to x. So it's like saying find d dx of each of these individual terms. And why does it feel like there are so many terms, right? Okay, so the derivative of y with respect to x. Well, y is not the independent variable. So I'm going to take the derivative of y, which is 4y cubed, and I'm going to multiply by the derivative of y, which is y prime. Plus, oh look, here's this fun little product rule again, the derivative of x times y. Okay, well the derivative of x is the derivative of x is 1 times the second function, plus, all right, the derivative of y is y prime times the first function. Got that? Okay. Derivative of x cubed is 3x squared. The derivative of minus x is a minus 1. And the derivative of 2 is 0. Okay, so I'm finding my derivative. My next job is to evaluate the derivative at x equals 1. But before I do that, I'm going to isolate this y prime. I'm going to get this y prime by itself. Notice I already have 2 terms with the y prime. And so, but I have 1 term that does not have y prime. So I'm going to subtract that y on both sides. And then I'm going to factor out the y prime on the left side. And I'm going to divide both sides by the 4y cubed plus x. Now I'm going to evaluate my derivative at x equals 1. And I know that I really have the ordered pair 1, 1. Remember, x and y make up the ordered pair. So when I go to find the derivative, the slope of the tangent line, I'm going to replace my x's with 1 and my y's with 1 because that is the ordered pair that I was specifically given to evaluate. And so I get 3 minus 1 gives me 1. And in the denominator, I get 4 plus 1, which is 5. Now I'm going to write the equation. Well, I have the ordered pair. I now have the slope. So y minus the y value equals the slope times x minus the x value. And there's the equation of my tangent line. All right, last one. It says find the equation of the tangent line at the point 1, 1 on this curve e to the x minus y equals 2x squared minus y squared. I'm just going to get you started on this, then I want to see how you guys finish this out, and I'll ask you about it tomorrow. Again, I'm going to take the derivative of each individual term. So when I take the derivative of e, remember the derivative of e is just the function itself. So that derivative is going to be e to the x, well, whatever was inside stays inside, times, I need to take the derivative of this entire exponent, okay, with respect to x. Well, the derivative of x is 1 minus, the derivative of y is y prime. And because that product is all related to the exponent and it's a binomial, I need to put that in parentheses to indicate that the e function is being multiplied by that entire derivative. Equals, derivative of 2x squared is 4x. Okay, the derivative of y squared with respect to x, that is not an x variable, so the derivative of y squared is 2y times the derivative of y. And before I leave you, my suggestion is to isolate that y prime, which means I need y prime terms on the same side. So I suggest that you distribute that e function. And then I suggest that you put the y primes on the same side. And it does not matter to me which side you choose. I personally tend to rewrite so that all of my y prime terms are on the left because I'm just used to seeing y prime finished off on the left. Okay, factor that y prime out. And then divide. And so I get y prime equals 4x minus e to the x minus y, all divided by 2y minus e to the x minus y. Your job is to go back and finish finding the derivative and writing the equation of the tangent line. All right, we'll work through some more problems tomorrow.